Okay, so this is the first session of our Math 2C lesson. This is more or less um, a new subject. Most of the parts I don't think you have already seen them before. Of course, some parts of it, for example, the lesson that I want to start here is a little bit of refreshing what you need to know from Math 1C in algebra part. This is not, it is not new at all. You already learned how to multiply polynomials, algebraic expressions together. Today I want to review that, and then I will let you to do the exercises in the book. Okay, so but the next sessions I will start teaching a little bit more because I want to cover hopefully everything in this book. Okay, so we want to multiply polynomials together. So the cornerstone of multiplying polynomials is a property from the real numbers. It's called distribution of addition over multiplication. So let me tell you what I mean by that. So for example, assume that you have A, B, and C be three real numbers. Yes, hopefully you remember. This represents the set of real numbers. This line we put next to R, this symbol is reserved everywhere to denote the set of real numbers. Otherwise, we just could simply write it R. Okay, and then this symbol means belongs to, yes. So this means that if A, B, and C belong to the set of real number, the simple way to say that is that if A, B, and C are real numbers. We know that we have this property that if I add these two numbers B and C first, and when I found the answer, I multiply A inside to the result. You can do it in this way. You can distribute this operation into this pair of brackets over addition. You can write A times B plus A times C. For example, if I want to give you a numerical example, so you can have 2, for example, times 3 plus 5. Of course, if I ask you to calculate this, because these are numbers, you usually do not do like this. You would say that, okay, 3 plus 5 is 8, so I would write 2 times 8. The answer becomes 16. But if you want to, you can also do it in this way. You can multiply this. You can take this 2, multiply it in the first term, multiply it in the second one, and then add the results. So you can write 2 times 3 plus 2 times 5. And if you calculate what is 2 times 3 is 6, what is 2 times 5 is 10. So you get 16, and you see that these two answers are equal. As I told you, when you are dealing with numbers, I don't think you will go and solve this problem in this way. Most of us will solve the problem in that way. But when it goes to algebra, we don't have any other choice. I don't know the values for B and C. So how can I add them? B and C are not similar, yes, because the letter parts are different. One of them is B, the other one is C, so B and C are not similar, so I cannot simplify this more than that. So if I want to do something and continue, then there is only one way to do that, and that is using this rule, which is called distribution. Distribution rule. Okay, so in algebra, if I am working with letters, this is inevitable. I have to use it if I want to expand it. Okay, but when I am dealing with numbers, I have two solutions available for me, but of course most of us will prefer this method. Okay, so this tells me that if I have addition here, and if I have a multiplication before the pair of brackets, If I want to multiply, if I want to expand, expand means getting rid of these pair of brackets. Write your expression in a way that you don't see any pair of brackets left. That is the meaning of expanding your expression. So I am expanding my expression. I am taking this and write it in a way that there are no pair of brackets left. How can I do that? I take a, multiply it into the first term, and multiply it into the second term, and then I am done. Of course, you can do it with more than two numbers in the pair of brackets. Yes, for example, if you want to, you can multiply a times b plus b c plus d. That's also possible. You can take a and multiply it here. It becomes a times b plus a times c plus a times d. And you have different versions. It doesn't matter from which side you are multiplying. If I have b plus c here and then multiplied by a, I can multiply a here from the left. It doesn't matter. So it becomes b times a plus c times a. And even if I have subtraction in between, this also will work. Why? But let me tell you why this will work. Because, for example, what happens if I have a dot b minus c? Okay, another way to look at this is to write b minus c as b plus negative c, yes? There is no difference between b minus c and b plus c. But if you call this capital C in your head, then you will face something like this. A dot B plus capital C. But what you can do, you can just do the same thing. You can write A times B plus A times capital C. And then when you replace capital C with negative C, this negative C will change this one to negative. So it becomes AB minus AC. Okay, so if I want to write something in front of it, it becomes a dot b plus a times minus c, but then this becomes ab minus ac. I never want you to do this, but I want you to understand that if you have a multiplication of an expression multiplied in the subtraction of two elements, you can do the same thing. You can take this one, multiply it here, and write it here, and then multiply this one once more here. But because this is positive, this is negative, the answer to the next one becomes negative. I don't want you to write these parts. I wrote them because I just wanted you to understand what's going on. But immediately when this is given to you, you can write this. Let me explain a little bit more about what happens if I have more than one term that I want to distribute. That's also possible, but I need to do it step by step. First, I show it step by step, but I want you to learn the rule and do it quickly. I don't want you to do it all the time, step by step. Once we have to understand that, after understanding that, it's better to do it quickly. So what happens, for example, if I have this situation, a plus b times c plus d. Okay, so of course, most of you remember what to do, but let me just review why this is possible. I would say that let us call this expression capital A. Okay, in my head, I give this expression a new name, capital A. Then what happens? It becomes capital A times C plus D. But I just learned that if I have one expression multiplied by the sum of two expressions or terms, I can multiply this here inside here using the distribution law. So what happens is this. It becomes A times C plus A times D. So I used distribution law one time here. I distributed capital A inside this pair of brackets. But now A was something that I bring in because I want to use this. So let me replace this name back to this. So instead of capital A, I can write A plus B multiplied by C plus A plus B multiplied by D. But now each one of them is a distribution law on its own right, yes? So you see, I use distribution law once here, and I am going to use two more distribution laws here and here. So in order to expand this, I have to use this distribution law 3 times. Okay, so then it becomes AC plus BC. I am taking this and multiplying it here, and then I will take this one, multiply it here, multiply it there. Yeah, so then it becomes plus AD plus BD. But I expect you to be able to write the final answer immediately without going through this procedure. But I want you to understand that why distribution law, because you know that in mathematics, whatever you have to follow exactly the rules. This rule is for 3 numbers, A, B, and C. But now for expansion of this, I have 4 numbers involved, A, B, C, and D. I cannot immediately and blindly use the distribution law here because distribution law is something for 3 numbers, but I have here 4 numbers. Then I need to think a little bit deeper. Can I connect this to this rule? The answer is yes, but the trick was to assume this is a number. So let me call it capital A. Then you see that how many numbers are involved. In this way of seeing the problem, I am dealing with 3 numbers. One of them is capital A, and the other 2 are C and D. Can I use distribution law? Yes, because distribution law tells me what to do if I want to expand this combination of 3 numbers, and I have that combination exactly of 3 numbers, so I can use them. After using it once, I replace this capital A with what it was. And then, can I use distribution law here? Yes, because I have 3 numbers involved exactly in this form. Can I use distribution law here? Yes, because that's the same combination with 3 numbers. So, but this is important. To come from here to here, you are using distribution rule 3 times. After understanding it, I myself will never do that. I try to do it quickly. What I do, I will take it in this form. I will have A plus B, C plus D. What I do, I will take this A and multiply it here and there. After it is finished, I will take the other one and multiply it here and there. Okay, so the first one gives me A times C plus the next one is A times D. The next one will give me B times C. The next one is B times D. Now, if you compare, I have a BD here, AC here, AC here, BC here, BC here, and AD here, and AD here. So that's also the same thing. So I myself always prefer to do it quickly in this way. Okay, another way to understand this is using geometry a little bit. For example, assume that you have a rectangle. So for example, let me call this one A. So assume that the length of this line is A, and then the length of this line is, for example, B. Okay? And then, for example, assume that you have the length of this one, for example, C. And then let me change the color here. And then after that, you have D, for example. Okay, so you have this one. Now let me complete this rectangle. Let me change the color to black. So I want to complete this rectangle. Okay, so if I ask you what is the area of this rectangle, the area of this rectangle is easy to calculate. If you want to find the area of the rectangle, you need to calculate the length. You need to measure the length and the width, and then multiply these 2 numbers. So if I ask you what is the length, for example, you would say A plus B. Yes, this is my length, for example. From here to here is A, from here to here is B. So the total length that I see here is A plus B. And then what is the width? The width is D plus C or C plus D. Yes, so it becomes C plus D. This is the area on the one hand. But you can calculate the area in a different way. Yes. For example, I can draw a line parallel to this lengths here, and I can draw a line parallel to these lengths here. Yes. And then you see that then I will have 4 rectangles. Yes. It's clear that if I add the areas of these 4 rectangles, I will again get the area back. So these two numbers should match. But if I ask you what is the area here, so let me call it A1, area number 1. Yes. So what is this area? I need to have the length, which is A, and then multiplied by the width, which is exactly equal to this length, that is C. So A1 is A times C. If I call this one area number 2, then what happens here? The area here is B times C. I write them. If you have problems, please let me know. Okay, if I ask you what is the area of A3 here, then I will see that I need to multiply this one, which is exactly equal to A, multiplied by this one, which is D. So this becomes AD. And finally, if I want to calculate area 4, I need to multiply this by that. This is clearly D, but this one is equal to B. So this becomes BD. So again, if I ask you what is the area, in one way of calculation, you got this. In another way of calculation, you find the area of each one of these partitions and then add them together. When you add them, it becomes AC plus area number 2 is BC, area number 3 is AD, and area number 4 is BD. And that's exactly what you get on the right-hand side. So if you want to see this problem from geometric point of view, that's also possible. Okay, so these are some rough ideas that we can use distribution law in this way that I was telling you. If you don't have any questions, what I want to do is to write some examples and try to increase our skills in doing this more or less quickly and with precision, okay, without making mistakes. No questions? Okay. So let me write here example. Let me fix the colors now. Okay, example. Expand and simplify. So by the way, this and simplify, I'm emphasizing. Even if I don't write it, implicitly always it means expand and simplify. I can sometimes say expand, but always I mean expand and simplify. Okay, so number 1. For example, let me start with simple one. So if I have 3x squared x minus, so let me write 2x to the 4 minus 2x plus 1. Okay, so I don't start with very, very simple examples because those are from Math 1C. Let us start from here. So I want to multiply this expression here. So here I have one expression outside. I want to multiply it over a pair of brackets. Inside the pair of brackets is the sum and difference of terms. But we learned that we can distribute multiplication both over addition and subtraction. It doesn't matter. Okay. So here, what I do, I want to expand. So let me write it with this color. So the green one is the solution. Okay, so I want you to do it in your head. For doing it in your head, might be you need to remember these formulas. If I have two exponents with the same base, if I want to multiply these two powers, if you remember, the rule was to write the base and add the exponents. Okay, So here, let me just do with this one completely, but I just want you to ignore this middle one. So in principle, I need to take this one, multiply it by this, multiply it by this, and multiply it by this. Okay, so let me write 3x squared, 3x squared multiplied by 2x to the 4. And then you see there is a minus, there is a positive, so the overall sign would be negative. And then I will have 3x squared times 2x. And the other one is 3x squared times 1. This middle one, I want you not to write, okay? I want you to do it in your head. Okay, so then what happens? I multiply these two. So for multiplying monomials, monomials means polynomials with one single term. There is no addition, there is no subtraction involved. That's a monomial. That's also monomial. If I want to multiply them, I multiply the numbers, so it becomes 6. And then I multiply these two. So then x to the 2 times x to the 4, according to this rule. Oh, I'm sorry. I don't know why this is missing here. So this becomes 6x to the 6. And the next one is negative. And then the same story here. 3 times 2 is 6. But then x to the 2 multiplied by x, x to the 2 multiplied by x. Another name for x is x to the 1. So it becomes x to the power of 2 plus 1. It becomes x to the 3. And then finally, I have 3x squared times 1, which is nothing except that one. And I know that all of you can do that. You should be able to do this quickly, and I don't want you to write this at all, okay? So is that clear? Just give me 1 minute. Okay. So let us do one more. So number 2. What happens if I have this situation? I have x plus 5 multiplied by x minus 3. I want to expand and, of course, simplify. By the way, I forgot to say, because it was trivial, can I simplify this expression more? No, because this term and this term and this term, none of them are similar, yes? So I cannot simplify this expression more than that, so that's the final answer. But let us go here. Here I have 2 terms involved and 2 terms involved. So this is more or less this idea, which algebraically means this. Okay, so I want to use this. So what should I do? I will take this one, multiply it here, and multiply it here. And after this is finished, I will go back and do the same thing with the second term. Yes? So let us just do this. The first one, what I write with green, is the solution. So this becomes x squared minus 3x plus 5x minus 15. Let me just once repeat. I multiplied x by this one. It becomes x squared. I still keep x and multiply it by minus 3 this time. It becomes minus 3x. When everything with x is finished, I switch to the next term. I take 5 and do the same thing. I multiply 5 by x, it becomes 5x. I multiply 5 by minus 3, it becomes minus 15. But if I stop here, that's not wrong. That's correct, but not complete, because these two are similar, and I have to continue. So I have to write x squared. I have these 2 terms similar. So this is one term, and this is the other one. I have minus 3x, 5x is added to it, so I will be left with 2 x's. So this becomes 2x. And then I have, of course, minus 15. And now this is the final answer. Okay. By the way, before simplification, you can have this idea how many terms are involved. So how many terms are involved here? 2, 1 and 2. How many terms are involved here? Again, 2, 1 and 2. But then 2 times 2 is 4. And if you see before simplification, you have exactly 4 terms involved. But when it is simplified, I will have 3 terms. So if you want to make sure that you are not ignoring one or some more terms, this is a good rule of thumb. If you have 2 terms, you multiply, it becomes 4. So before simplification, you have to have 4 terms. If one of the terms is missing, you immediately realize that you need to recalculate. Okay, for example, here, how many terms I have? I have 1 term. How many terms here I have? I have 3 terms. So 1 times 3 is 3. And you see that before simplification, of course, it was not possible to simplify in this case. It is 3 terms. It contains 3 terms. Okay, so what happens, for example, for this case, number 3, I have, for example, 2x minus 5, then I multiply it by x squared plus 2x minus 3. Okay, so the story is the same, actually. So what I do, I break it in my head into 2 terms. I break this into 3 terms. Each one of the terms on the left should be multiplied by every term on the right. Okay? So, and then don't get confused. You need to develop a habit in your brain so that you do it systematically. If you do it randomly, of course, at the end of the day, if you consider all cases, that's correct, and you will get the full mark. But from my experience, it is hard. So let us organize your brain, yes? So I will take this one, I multiply it here, here, and here, and when it is done, I switch to the next term, yes? Even though this is not an obligation. Okay, so what I do, I will multiply 2x by x squared. It becomes 2x cubed. Then I multiply 2x by 2x. Both of them are positive, so it becomes positive 4x squared. Then I multiply 2x by minus 3, so it is clear that the answer should be negative 6x. Now that I am relieved that 2x is done with all the terms, I go back and choose this term and do the same thing. So I multiply minus 5 here, here, and here. The first one becomes negative 5x squared. The next one becomes negative 10x. The next one becomes positive 15. Again, let me double check that I haven't ignored any term. How many terms are involved here? 2. One of them and 2 of them, so there are 2 terms here. How many terms are involved here? 3. 1, 2, 3. And what is 2 times 3 is 6. So before simplification, I have to have 6 terms. Let us double check. 1 term, 2, 3, 4, 5, 6. So this doesn't guarantee that I haven't done any mistakes, but at least this guarantees that I haven't ignored any term. Okay, but can I stop here? No, because of this implicit word here, simplify. So I need to find the similar terms. Are there? Yes. Here, 4x is similar with this one, similar to this, and these two are also similar. So I have to consider these two. So what happens is this. 2x to the, sorry, I have to change the color. So 2 to the power of x3 is alone, but I have 4x squared here, positive, minus 5x squared becomes negative 1x squared, but nobody writes negative 1x squared because there is a simpler, more compact name for it. People call it minus x squared, yes? So we write minus x squared, and then I have minus 6x minus 10x, it becomes minus 16x. And finally, I have positive 15. So you see that this is the answer to this problem. Any questions? Okay, good. Let me practice a little bit with fractions, of course. The fractions, so I'm just, the lesson is not hard at all, so you know what to do. So this is a technical lesson. It means that you need to improve your skills, your computational skills. So let me give you another example for what happens if I have this situation. For example, let me write 2x over 3 plus, what can we write? For example, y over 5, and then let me multiply it by 3x divided by 2, and then I will have plus, let me take one of them negative, negative 2y over 7, for example. I want to explain, I want to expand and simplify this expression. The story, the method is the same, but you need to be more careful because you are you are dealing with fractions. I don't know, I have seen some students sometimes make a mistake. They multiply by the common denominator to get rid of the fractions. I don't know how many of you think in this way, but I want to mention that be careful, this is not possible here. If you remember in the Math 1C, I always tell that I hate fractions, so I get rid of them as soon as possible. But I need to say it more complete. That is possible only if I have equality and then I multiply both sides of equality by the common denominator to get rid of the fraction or the fractions, yes? So this is different. You see, for example, let me write it in this way. If I have a to the divided by 3 equals to b divided by 2, can I multiply by 6 to get rid of the denominators? The answer is yes, because here is equality. I am multiplying both sides by 6. This means that, why this is valid? This means that if you tell me that these two quantities are the same, it is clear then 6 times this quantity should also be 6 times this quantity. So this is the logic behind this. Okay, here I can multiply by 6, then 3 and 6 are gone. This becomes 2a, so I will have 2a. On the right hand side, 2 and 6 are gone. I will have 3b. So it means that if you tell me that this equality is legitimate, I can also conclude that this one is also true. This is the meaning. But if I give you a over 3 on its own without any equalities, of course, it would be very nice to get rid of the fraction here as well, but this is not possible. You cannot say that, look, I multiply by 3, and then 3 and 3 are canceled, then I have a. Then what? This is not valid. I want you to understand that. Here, I do not have equality. I have one fraction on its own. That's it. So I have to work with that fraction. Yes? But if two fractions or two expressions involving fractions are equal, if I want to, I can rescale both sides to get rid of fractions. But for example, here, can I multiply by the common denominator to get rid of the fractions? No, because you don't see equality sign. There is no equality sign here. In the same expression, even though when I want to write, I myself put equality sign and continue, but on the right hand side of equality, I am just writing in something similar, equal to this expression. This expression on its own doesn't have any equality. So this seems a little bit irrelevant, but this is my experience. I have seen some students sometimes do this. I want to make sure that you don't make this mistake. Okay, so what can I do? Another thing I want you to, at this level now, you are in the second stage of the first year, so you are a little bit more skilled. So I hope that you immediately see there is another name for this. All of you should be very quick in understanding these things. So 2x over 3 is another name for 2/3 times x. Okay, let me just explain it once, but promise yourself and me that you will never forget these things. Okay, so if I have 2x over 3, another name for this is to write 2 over, so how can I write this? So here I can write 2 times x over 3 times 1 if you want to, because 3 times 1 is the same as 3. And then you know that you can write it as 2 times 3 times x over 1. But no one writes x over 1. People write simply x. And this becomes this. So hopefully you will not have any doubt that this and this are exactly the same. They are different way of writing of the same number. 2x over 3 and 2/3 of x. They are exactly the same thing. Okay, so if you need, you can use these ideas. Okay, now let me make the explanation short. So I will take this one, multiply it here and there, and then I will go back and take this one, multiply it here and there. Okay, and then hopefully you remember from Math 1C that if I have two fractions, a over b and c over d, if I want to multiply these two, in principle, I multiply the numerators, I multiply the denominators, but I don't want you to do this all the time. Remember that there are two ways of simplifications possible, two ways of simplification. One of them is, do you remember? Vertical manner. If it is possible to simplify A and B and C and D, do it. There is also another way of simplification, and that is cross-manner way. You can simplify the numerator of one of them with the denominator of the other one. So I would prefer to simplify and continue. I always tell you that in algebra, it is much efficient to do this first and then continue. Okay, so this is why, if you don't mind, let me write this explicitly. So 2x third over 3 multiplied by the first one, 3x over 2. Yes? And the next one is this one multiplied by that one. So this is positive, this is negative. So then the answer would be negative. But I have 2x over 3, and then I have 2y over 7. Then I'm done with this one, so I go to this one and do the same thing here and there. So this becomes plus y over 5 times 3x over 2. And the next one again becomes negative because one of them is positive, the other one is negative. So y over 5 multiplied by 2y over 7. So here, for me, it doesn't matter if you write this intermediate step. If you can do it quickly in your brain, it's even much better. Okay, so what can I do here? For example, in principle, I can multiply these two in the numerator and these two in the denominator. So in the numerator, you get 6x squared. In the denominator, you get 6. And then, of course, because we are supposed to simplify as much as possible, so you have to simplify these two 6's. Here, it is not that hard. So even if you do this, this is not that important. But try to develop this habit in your brain. So this 2 and that 2 are canceled. The denominator of one of them can be simplified with the factors of the numerator of the other one. This one and that one can also be canceled. So what is left for me is x, and this x is left. So just x squared. Okay, and then here, so I cannot simplify anything with anything. Vertical simplification here and there are not possible. Cross-manner simplification is not possible, so I have to multiply. So 2x multiplied by 2y is 4xy, but I have a negative sign here, so it becomes 4xy, and the denominator becomes 21. Yes? And I go here. So what is the number which is not written here? This number, by the way, is called the coefficient of the numerator. These numerical values multiplied by that expression are called coefficients. So this is 1, this is 5. Vertically, it is not possible to simplify. Vertically, not possible. Cross-manner way is also not possible. So we have to multiply. So then it becomes 3xy. And in the denominator, we will have 10. And finally, in the last one, let me just write it without explanation. So it becomes minus 2y squared divided by 35. Let me know if there is something that you don't understand here. Okay, now tell me if you understand. Should I stop here or can I continue? Yes, can you hear me?
Yeah, I can hear you.
Yeah.
Okay, do you think that this is the end of the problem or should we continue?
I think it's the end.
Yeah.
So is it the end or not?
Yes.
It's not the end because we have two similar terms, maybe. Because we have
Yes,
4xy
exactly.
and 3x.
The middle ones are similar, even though they are written in a disguised form, but you shouldn't be fooled by this way of writing, yes? Are these two terms similar? Similar terms are the terms that they have exactly the same letter parts, okay? But I told you, what is another name for this? Another name for this is minus 4 over 21 xy. This is something I really want you to understand immediately. Do you have any problem understanding this?
No.
Okay.
No.
So this is something. And what is another name for 3x over 10, 3xy over 10? Another name for this one is 3 over 10 xy. Now look at the structure of these two. Do you see the similarity? The letter part here is xy. The letter part here is exactly xy. So they are similar. Okay? So this is something that you need to immediately understand. So this is not hard at all. Okay. So let me just expand this a little bit. This is from understanding point of view. Don't think that I am changing the rules. No, I am following exactly the same rule. If I give you minus 4xy and I ask you to add it to 3xy, this is so simple that you do it quickly and probably you don't pay attention what you have done in your brain. So what's the answer to this?
Minus xy.
Minus xy. How did you do that? In principle, you did this in your brain. You said that xy is xy. What you did in your brain is to take the coefficient from the first one, which is minus 4, and the coefficient of the second one, which is 3. You did all these things very quickly in your brain, and then you realized that this is nothing except minus 1, and then you wrote minus 1 xy. If you really want to go to your brain, pardon? Pardon?
Sorry, it was accident.
Okay, no problem. So you will get this minus xy. But you did it so fast because it was so simple. You never, you didn't go through this to calculate that. In principle, you did the same thing. If you think a little bit deeper, you actually did it, but did it very fast. But when the numbers are fractions, if you are very skilled, might be you can do the same thing very fast with fractions, but usually we cannot do that. But the method is not changed. The method is exactly the same. So if I want to understand what's going on here, so let me write this one with also this color. So let me write this once for all, then you can choose whatever you want to do. You want to do it in your head, you want to write it in a scratch paper, come back, that's up to you. But you need to think in this way. This is another name of this expression. That one is another name of this expression. I want to do the same method. The problem is that it is hard for my brain immediately answer what is the sum of these two fractions. Either you use your calculator or you go to a scratch paper, but you know what to do. You are supposed to add this fraction to that fraction, and then whatever you get, you put an xy in front. So what I am doing now, I am doing this in the scratch paper. So my duty is to calculate this now. So hopefully you know how to calculate this. You need to find the common denominator, which in this case is 210. And then you would say to yourself, 210 divided by this is 10 times. I multiply 10 here, but I have also a -1, so it becomes -40. And then this one divided by this is 21 times. You multiply 21 here, it becomes 63, and you have a plus sign. And then it is easy, by the way, so this becomes 23 divided by 210, and then you put it back here, so you will get your answer. When you are done, you go back here and finalize your answer. So if I want to go, I have to go one more step. It becomes x squared, and then I will have plus 23 over 210 xy, and finally I will have minus 2y squared over 35. Okay, so you see that it is of course more tedious, but the strategy and techniques is the same, but you need to be a little bit more patient to calculate these things. And of course, if you have your calculator in the fraction mode, it's very important not to write them in decimal points because we want to have exact values. Okay, any questions so far? Okay. Another thing that I want to mention here, so far you see I have two expressions multiplied together. But you know that in numbers, when you were in primary school, it's an easy question to ask what is 2 times 3 times 5, for example. It is not a strange question. I want to multiply 3 numbers. How do you do this? You multiply 2 by 3, you get the answer 6, and then multiply 6 by 5. Be careful. When you are multiplying these 3, you don't multiply it here and there. Yes? When you have 2 times 3 times 5, you decide. For example, you decide to multiply these two things first, it becomes 6, and then you multiply the answer to the third one, it becomes 30. And of course, it doesn't matter if you want to group these things together first, because then the answer becomes 15, and then you multiply 2 by 15, but you get the same answer. That is also true if we have these brackets. So this is also something we didn't have that much. Of course, I talked about this in Math 1C, but this is formally one part that you need to learn here, okay? So here, number 5, let me write this one. For example, x minus 1 times x plus 2 times x minus 3. So I want to multiply this. So what should I do? You see, I have 3 polynomials involved. And these are not numbers. If they were numbers, of course, it was easy. I multiply these two things, I get the answer, I multiply it by the third thing. But this is algebra, so that the same rules actually apply here. But of course, it is more tedious. I multiply these two first. I do not touch the third one. And after I found the answer, I multiply the answer by the third one. This is the way, exactly as I am working with numbers. By the way, in algebra, these are numbers. X is representing a number, even though we write it as X. But that is at the end of the day, it's a number here, it's a number here, it's a number here, but an unknown number because the variable value is not known to us right now. Okay, so if I want to solve this problem, I would put equality sign. I decide, for example, I say it is it is possible to multiply these two first and then multiply it here. It's possible to multiply these two first and then multiply it here. Even it is strange, but this is also possible to multiply these two first if you want to, and then find the answer and multiply it in the middle one. All of them are equivalent. But why we should go to trouble? Yes, so let me do this in order. So what I do, let us put open a pair of brackets. In this pair of brackets here, I want to write the answer to this part. That is very easy because this is the product of two pair of brackets. We learn what to do with that, yes? So x times x becomes x squared, x times 2 becomes 2x, minus 1 times x becomes minus x, minus 1 times 2 becomes minus 2. But if you are in hurry and go to the next step, that is wrong. Because in mathematics, you need to respect the punctuation and the rules and everything. So when you say equality, it means that this should be indeed equal to this. But if you are in hurry and jump to the next step, this is not right. So let me clean this. You need to be careful. You have to copy and paste the last part that you are not touching. Then you are allowed to put this equality. And then, of course, you can continue. This is up to you. I myself prefer to simplify and then carry on. If you are in hurry here, it doesn't matter. You can start multiplying. Sorry, you can take this one, multiply it here, and take this one, multiply it here and here. But of course, here I have 4 terms. Here I have 2 terms. At the end, I will have 8 terms. But if I simplify this, for me, it is better. And I really recommend you to do this one. So before continuing, I see that these two are similar, so I simplify them. 2x minus x is just simply positive x, and then I have minus 2, and then I have x minus 3. You see, again, I copied and pasted this x minus 3. Now I go to the next step. I take these 3, multiply them one by one here and there. So this becomes x to the 3 minus 3x squared plus x squared minus 3x minus 2x plus 6. Yes, so I took this one, multiplied it here and there. I got these two. I take this one, multiplied it here and there. I got these two. And finally, I take minus 2, multiplied here, I get minus 2x. Multiplied by minus 3, I get positive 6. But it is not finished yet because I have similar terms involved. So here I have this one and that one similar. I have these two similar. So the next step is to write x to the 3 minus 3x squared plus x squared is minus 2x squared. And then I have minus 5x plus 6. And this is the end of this problem. Okay, any questions? Okay, so one more example here. What happens if I ask you to expand this? What should I do here? Any ideas?
You should multiply the entire bracket by itself.
Exactly. So that I am very happy that you are not confused with this situation. So you see that we have a times b to power 2. If this is times, if it is multiplication, then you're allowed to write this. But don't think that because this is valid for multiplication, it is a priori guaranteed that this is also valid for addition, which is not. If you write this, it is not correct. Okay, so you cannot just raise this one to power 2, raise this one to power 2, because this is subtraction. So as Gustav said, so the first step, which has to be in the exam, is to write this 2 times. Why? Because that is the meaning of power 2. If someone asks, what is the meaning of this expression to power 2? It means that this one multiplied by itself. And then this is a normal problem now, so you know how to expand this. So let me just do it quickly. X times x is x squared. The next one is minus 2xy. The next one is minus 2yx. And the next one is positive 4y squared. Okay, but the letter parts are actually exactly the same because xy and yx, xy means the product of x with y, yx means the product of y with x, but you know that product doesn't matter, in product doesn't matter. So these are similar. So the answer is x squared minus 4. If you want, you can write xy or yx. That's both of them are correct. And then I would write 4y squared. Okay, now, yeah, I just teach for 5 more minutes, then you have 30, you will have 25 minutes to practice, okay? Because I saw these are different types of examples that you will face in the book. Let me change the problem to this problem. So here, example. Solve the following equations. So you see the terminology that I am using, I'm not saying simplify, I'm saying solve. Solve an equation. First of all, you see here, these are not equations, these are expressions. What I wrote in blue doesn't include any equality. So if I ask you what we call this in algebra, you would say that is an algebraic expression. That is an algebraic expression. But equation means equality between two algebraic expressions, and we cannot say simplify an equation. The word that we have to use is solve the equation. Solve the equation means find the value for the variable in that equality so that the equality becomes true. So for example, if I cannot write this in the exam and ask you solve it, because this is not an equation, this is an algebraic expression. If I want to, I can say simplify it. I can say, for example, expand it, factorize it, these kind of words that we will be familiar with. But I cannot ask you solve it. There is nothing to solve. But if I give you the same thing equal to 0, then I cannot ask you simplify it. It's not a good word here. I can ask you solve it because this is equality. I need to find that value for x so that this equality turns out to be a true equality. Because it is clear, for example, if I choose x equal to 1, the left-hand side becomes 2 plus 3 is 5. 5 equal to 0 is false. So this means x equal to 1 is not a solution to this problem, to this equation. But if I want to find that, you already know what to do. I don't want to talk about that. I will explain it here. When I say solve it, it means that find the appropriate value for the variable so that if you replace that value, if you substitute that value inside the equation, the left-hand side and the right-hand side become indeed the same, true. The equality becomes true, okay? Of course, I want to let us, for example, solve this simple problem first. Yeah, these problems are not hard actually. So let me choose this example. So x plus 1 times x minus 8 is equal to x squared minus 152. So we want to solve this equation. Oops, let me get rid of all of them. Okay, so how should I solve this? First of all, I hope that this makes sense. Solve makes sense here. The left-hand side itself is algebraic expression. The right-hand side itself is an algebraic expression, but you see the equality between them. So this is called an equation. It is not an expression. And when we are dealing with an equation, the good word for it is to solve it. It means to find the appropriate value for the variable x here. Okay, so of course, one main part of solving the equation is to simplifying each side of the equation. That is, of course, true. We have to simplify. But we don't say simplify, we say solve for an equation. Okay, how should I write? So what I write with green is considered to be the solution to this problem. Okay, we just learned that if I want to solve this, this is a little bit hard, so I try to simplify as much as possible. The right-hand side cannot be simplified because these two expressions are not similar, so there is nothing that I can do there. So let me keep copy and paste. But just now we learned what to do here. We just expand this expression. That's the only way that might be will solve our problem. So if I expand that, this x times x is x squared, x times minus 8 is minus 8x, and then 1 times x is x, minus 1 times minus 8 is minus 8. Okay, for the first part of this course, if I give you a question, x squared should vanish. Because if this doesn't vanish, then you will face an equation which is called a quadratic equation, and that would be a main part of this chapter, to learn how to solve quadratic equations. An equation is called quadratic when the power of that variable that you are looking for is 2. The highest power is 2. Okay, but this is apparently a quadratic equation because you see x squared appears, but immediately it will cancel out. So that is not a problem right now. In the future, we will learn that if x squared does not vanish, we still can solve the problem, but the technique is different. We haven't taught that. I haven't taught that to you yet. Okay, so what I do, I simplify things. The left-hand side still can be simplified a little bit because I have two similar terms. Let me copy and so let me just write it. It becomes minus 7x minus 8, and then I have x squared minus 152. So it is not hard to see that if I move x squared to the left, this becomes minus x squared, and this minus x squared and this one are similar and opposite, they will cancel out. Okay, and then I move this number to the right, it becomes positive 8. So let me write everything here. So I would write x squared, I will keep minus 7x. I move x squared to the left, it becomes minus x squared. What is left on the right is negative 152. And then I move 8 to the right, it becomes positive 8. So this one and that one now are gone. What is left for me is minus 7x. And on the right-hand side, what is left for me is minus 144. Yes, am I right?
Yes.
And then I want to find x. So it is minus 144 divided by what? Minus 7. Yes, can I simplify that? I don't think so. So it becomes 144 divided by 7. So that's the final answer to this problem. If someone asks you what is the meaning of this number that you found, you would say that if I go to my original equation, I take every x away and replace this number inside, and I calculate the left-hand side and the right-hand side, the numbers that I get are equal. That is the meaning of the solution of an equation. Okay. So to make sure that you can do these things correctly, I want to make this a little bit harder, and I want to wait for you. So consider this as a part of exercising session, okay? And by the way, from now on, whenever I teach, I will write on a Schoolsoft which pages you need to read and do the exercises, okay? So let me write the question here for you. Hopefully I can fit the solution as well here. Let me write it a little bit higher here. Save space. So I will write this equation for you and give you 5 minutes to solve it, and then I will solve it if you don't know how to do it. Yeah, this you need to be a little bit careful. It's not hard. It might be a little bit more tedious. So let me double check because the numbers are important. Otherwise, it turns out to be a quadratic equation that we cannot solve right now. Yes, you can solve it now. So I pause the video, wait for you for 5 minutes so that see how we can just do it. Okay, so can you read your answer for me?
If I'm correct, the answer is x is equal to 22 divided by 15.
22 divided by 15. That's not the answer I got. Of course, I did it very quickly. Might be I have done some mistakes. Any other answers?
I got -2/9.
I got the same as Rocco.
Yes, that's
Then
my
I'm
answer.
probably wrong.
Yeah, okay. So I think because I also got this one, then I think it's not, yeah, it's highly unlikely that we get something -2/9 all the same. Yes. So might be this is the correct answer. Let me see. And please, if you haven't got this answer or the answer that we will find at the end, please let me know if you really don't understand what's going on or you have miscalculated. Because if you don't understand something, you have to ask me. But if you understand that you have done some miscalculation, that's up to you to practice more to increase your skill. Okay, so let me just be patient and do it. Okay, so let us, first of all, when I see to solve this equation, it's a big equation, so I need to be patient and simplify this, even though the word is solve, but I told you exactly as the previous example, if I want to solve, it's better to simplify and solve. It's not possible to solve it in this way. Okay, but the only way that comes to mind to simplify the left-hand side is just expand. Okay, but be careful, expansion here involves 3 terms. Of course, one of them is one single number. It's not a big deal, but I want you to understand there are 3 numbers involved. So again, the rule is the same. You have to multiply 2 of them. When you found the answer, you multiply the answer to the last one. Okay, here, this is a power of 2. And then we learned exactly in this exercise how to deal with the power of 2. This is 2 terms to the power of 2. Okay. So if I want to write this, I use my experience from the previous exam. From the previous question, I multiply these 2 first. But you need to be careful so that you have to copy and paste what is left. So I multiplied 3 inside, it becomes 6x plus 3. And then I copy and paste the other one. I put equality. Don't be tempted. I don't know, might be some of you simplified these 2 first and wrote 10. If that is the case, let me explain that this is not possible. If I give you 16 minus 6 times 5, for example, let me make it simple. If I ask you 16 minus 6 times 2, how do you calculate that? I don't know. For some reason, if I give you this, most of you, or more or less 100% of you, will give me the correct answer. You, I don't know, somehow you realize that you have to multiply this first, 12, and then 16. There is no rule for that. There is a convention behind that. And that is, when I have the product and subtraction, by convention, the product has the priority. So this is why you don't see any pair of brackets there. In principle, I should have a pair of brackets to prioritize the operations, because here there are two operations involved. Which one I have to do first? The answers are different. So the reason that you don't see any pair of brackets to prioritize the operations is because we have this convention that if there is a subtraction or addition and there is a multiplication, the priority is always given to the multiplication. So if I ask you to calculate this, you will never subtract these two and write 10 and then multiply it by 2. This is not right. And that's the same story here. I don't know how many of you might have thought about this, but let me be on the safe side and explain it again. So here you are not allowed to do this one first, because what is between 6 and this expression, how complicated is that? We don't care. This is something. And then the operation between 6 and that something is a product. And then I have a subtraction. And we know that the priority is given with the product. But again, can I multiply 6 inside to write 6x minus 6 then to power 2? If you have done this one, this is also wrong. Why? Because there is another rule. The priority is with power. Okay? So if you have 6x minus 1 to power 2, you cannot choose to do the product first and then the power. If I am facing a product and a power, the priority is with the power. Okay? So considering all these things, what you need to write is to write 16. We cannot do anything with this 16 right away. And then I would write 6, but I know what is another name for x minus 1 to the 2. It's just simply x minus 1, x minus 1. Okay. Any questions so far? Okay, so let me now go to the next step. The next step is a little bit more clear here. I am facing the product of these two polynomials, so I just simply multiply them. Let me do it a little bit quickly. So this becomes, this becomes 24x minus 6x squared. Then I go to the next one, it becomes 12 minus 3x. But again, I am not allowed to subtract 16 and 6. But again, here I have a product of 3 terms. Okay, that's up to you. Again, if you want to, you can multiply these two first and then multiply 6 in. Or you can multiply 6 in first and then multiply it with the other one. It doesn't matter which way you do it, but you need to exactly know what to do. So if you don't mind, let me multiply these two first and then copy and paste this part for the time being. Okay, so I put a pair of brackets. What I want to write here is the content of this product. So then this becomes x squared minus x again plus 1. Why 2 minus x's? X times minus 1 gives me 1 minus x. Minus 1 times x gives me the second one. And then minus 1 times minus 1 is positive. Yes? Okay, let me go to the next step. So 24. Do you have any questions?
Lina, muta.
Yeah. So what we should write now, on the left-hand side, these two terms are similar. I don't have any more similar terms. 24x minus 3x is 21x. Minus 6x squared plus 12. On the right-hand side, again, don't be in hurry, so you need to write 16, but this time you multiply. I prefer to multiply minus 6, all of it here, 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 and there. Of course, here you can simplify first. Let me simplify, yes? So this becomes x squared minus 2x plus 1. So this is why I'm telling you, in algebra, you need to improve your skill a lot so that you can do a lot of things quickly. It's so sometimes, yeah, I don't respect these things because I want to do it quickly, but you can also practice. In principle, I have to simplify this one. It's better to simplify and then continue. Okay, I made a mistake here. Yes, because here 24x minus 3x is 21x. I forgot to write the x. Okay, so then this becomes 21x minus 6x squared plus 12. On the right hand side, I will have 16 minus 6x squared positive 12x negative 6. I took this negative 6 and multiplied here, here, and there. Again, don't worry about this quadratic term because you see, we only know how to solve this one if this is cancelled. And the good point, this will be cancelled. So let me write 21x minus 6x squared. And I move everything including x to the left-hand side. The next, this becomes positive 6x squared. This becomes negative 12x. So I took these two and moved them to the left. But there is 12 here, I move it to the right. So I have a 16 there, minus a 6, I move 12 to the right, it becomes negative 12. And then this one and that one, fortunately, cancel. And then what is left for me is 21x minus 12x, which is 9x. On the right-hand side, 16 minus 6 is 10, 10 minus 2, 10 minus 12 is minus 2. And as you said, the answer is minus 2 over 9. That's the final answer.
I just miscalculated mine. I found the place and sent it.
Okay, good. So I just want to say, because this question is actually a level 1 question, I would say. So because even though this is not hard, but it demands a deeper understanding about the priority of operations, which is a very important thing in algebra. Otherwise, you might misinterpret your expression and reach to another answer, which is wrong.
Did you say this was a level 1 question?
No, A, the highest level.
A level. Okay.
Yes, A, yes. Okay, so if you open your books, I would write everything on a school soft. So I will open a new playlist on YouTube. I will upload this video there. Below the video, you will find the link to the lecture notes that you see on the display now. And then what I covered is page 8 and 9 in the book. I recommend you to start reading the text on page 8 and try to solve as many problems as you can on page 9. Even if it seems simple, I want you to train your hand to write faster and faster. Okay? I will write the details on a school soft, but this is just I told you orally. If you don't have any questions, let me stop this video. And if you have some questions, we can still chat a little bit. So I see some